HMD Kontro sealless magnetic drive pumps are often used to pump a wide variety of hazardous liquids. These can include flammable, highly explosive, or highly toxic liquids. The construction and operation of sealless magnetic drive pumps are well known. This video explains how secondary containment as a design option is achieved to further enhance process safety. It is important to explain the difference between the primary and secondary pressure boundaries of the magnetic drive pump. The primary pressure boundary comprises the pump casing, generally a thick-walled cast component sealing the process to atmosphere, and a thin-walled containment shell between the two parts of the magnetic coupling. The containment shell is located inside the magnet coupling housing, which may, as a design option, be sealed to form a secondary pressure boundary. A dry-running mechanical seal between the rotating shaft and the static coupling housing completes the sealing of the secondary pressure boundary. In the unlikely event of a primary pressure boundary failure involving the containment shell, process liquid is contained within the secondary pressure boundary. With the secondary containment design option, a level of pump instrumentation is needed to alarm and shut down pump operation should a primary pressure breach occur. This instrumentation comprises a pressure sensor and/or a liquid sensor fitted to the magnetic coupling housing. For low vapor pressure liquids, a liquid sensing probe is used. For high vapor pressure liquids, a pressure sensor. These need to be set to stop the pump immediately if a leak is detected. With magnetic drive pumps, a gap exists between the magnetic coupling driveshaft and the coupling housing. The gap is sealed by a dry-running mechanical seal. Under normal operating conditions, the two faces of the seal are non-contacting. In the unlikely event of a primary pressure breach, the instrumentation immediately stops the pump, enabling the mechanical seal faces to close. As the liquid builds within the outer shell, the area surrounding it is filled with the liquid, but the secondary containment seal prevents any leakage. Pressure can build within the secondary pressure boundary, and the mechanical seal will contain the liquid, preventing any leakage to the outside atmosphere. Once all the liquid has been contained and the pump isolated from the system, the contained liquid in the secondary and primary housings can be drained safely, the pump fully decontaminated and then inspected. The following sequence is a live demonstration of the HMD Kontro secondary containment system. This demonstration of secondary containment comprises an HMD Kontro general service pump. It has been modified to allow process liquid, which would normally flow into the rear of the pump, providing lubrication for the internal bearings and cooling for the magnetic coupling, to be diverted into the secondary pressure housing, where the outer part of the magnetic coupling is spinning in air. The pump has a dry-running mechanical seal positioned between the secondary pressure housing and the bearing housing. The bearing housing vents to atmosphere. A pressure gauge monitors the pressure in the coupling housing, which in atmospheric air reads 0. A liquid level probe is also positioned to detect the presence of liquid in the secondary pressure housing. A hole is positioned at the bottom of the bearing housing. The magnetic drive pump is switched on, running at 2 pole speeds. The magnetic drive pump is piped to a water test tank with the valve on the discharge pipe providing a system resistance, and the discharge valve is adjusted to set an 80-meter discharge head. In normal operation, the secondary housing pressure reads 0, and the green LED on the liquid level probe indicates that it is operational but not activated. A pressure boundary breach is simulated by opening the feed pipe valve of the test pump. Water or process liquid fills the secondary pressure housing, which increases to the discharge pressure. The liquid sensing probe detects the presence of liquid in the secondary pressure housing and is set to immediately stop the pump. A tube connected to the coupling housing for this test shows the level of the process liquid in the coupling housing. Having isolated the secondary housing pressure by closing the feed pipe valve, the pump is manually switched off. When the pump has stopped rotating, the discharge pressure reduces to 0. The mechanical seal has stopped rotating with the pump, and no leakage is evident from the bearing housing drain. The system pressure and process liquid is contained. After a period of time, with the system pressure contained in the secondary pressure housing, the pressure is relieved. For your magnetic drive pump requirements, either with or without secondary containment or control, please contact HMD Kontro.